Hello everyone. Welcome to this meeting where we are starting our webinar series. So let me give you a brief intro about how embedded innovators started. So back in November 12, 2022, this group was created with an aim to share knowledge, connect with like-minded people. Now fast forward to today, we are starting a you know a community where we can build products right from scratch, and finally a product which will be ready. So we all will be freelancers of the embedded world. Now coming to the fact, what is embedded innovators about? We are having an aim to build a dream team where we will build things right from scratch, make it a product ready. We'll be contributing to various open source projects and all. So let us see where we reach. I'll introduce to you Sumit, who is going to be taking your mentoring sessions on STM32. Over to you, Sumit. Please go ahead.
Thank you, Muskan. Hello, everyone. My name is Sumit, and I have over 3.5 years of experience in the embedded domain as a professional C developer. And currently, I am working as a senior application developer in ST Microelectronics, Greater Noida. So I've been the part of this group not long ago, but I kind of jumped into this project. So to share my STM32 knowledge and to build something from scratch. I wanted to do it on my own, but different things come up and I don't get started. So I think the community is the best way to collaborate and do something from scratch. You get a lot of support from the community. So it's better to be in a community than do it all on your own. So coming back to, I think we have only 4 members here joined in, right? Yeah.
Yes.
So if I would encourage you all to turn on your camera so that we can have a two-way communication. So I want it to be a two-way communication so that you can stop me and ask me questions, because I don't know how much experience you guys have and what knowledge you have. So I might be skipping something, or if I'm explaining it too much, you can stop. Okay, we know this, you can go ahead. So that way this can be meaningful. If uh, if you are okay, you can turn on your camera. Otherwise, I will go ahead. And please feel free to interrupt me and ask me any questions. So let's get on to our agenda. I'll share my screen first.
I'll make you the host if you're not able to share.
Yeah, I'm able to share it.
Okay, okay.
Okay, is it visible?
Yeah, it's visible.
Okay. So I have my Cube IDE installed. This is the latest Cube IDE with me. And you don't need to install the other tools from ST that are called CubeMX or Cube Programmer. Because all of these things are integrated in this integrated development environment that we have. This is ST-Cube IDE. So in order to get started, you just need to install this piece of software. I hope you have any one board with you, either it is Nucleo or Disco. We are working on F4. Muskan, I don't have, I'm not seeing the chat. If any question is put on the chat, I can take it later.
Yeah, sure.
Okay. So this is the Cube ID open with me. This is the latest one. First of all, let me show you how we can configure different peripherals. Or I will take only the GPIO or RCC, configure these peripherals using a visual tool that is CubeMX in the Cube IDE. So we will configure them and we will generate code for them. So you can just click on create a new STM32 project here. 1 second, I will move. Okay, yeah. I had the zoom controls over my screen. I have. Okay, so I will create a new STM32 project. I will click on it and then it will show me a target selector application. Okay, so we have the target selection application with us. So we know we have the F401 MCU and we have a I personally have a Nucleo board. So I will show you code generation with that code. So the board, there are two different things I want you to understand. There is a MCU or MPU selector and there is a board selector. We can have one MCU with different boards. For example, we have F401 RE and someone might have a Nucleo board and someone might have a Disco board. But the MCU that is on that chip, on that board is the same, that is F401. Okay, so for example, we are on the board selector and I'm selecting F401 RE. Okay, so I got Nucleo F401 RE and here on below I got the board. I can just click on it and here it shows some features of the board and some docs and resources. Now I want you to download three main documents from this target selection application. The documents are, one is for the board, for the Nucleo board, we have a schematic. So a schematic is a document from which you can see where the LED or where the user push buttons are, where they are placed, to which GPIO pins they are connected to. I will go through the schematic once again later in the session. So one major piece of document that we want from the board selector tab. So because the schematic is related to the board, so we will get the schematic from the board selector window. And we have three different schematics mentioned here. So if you turn around your Nucleo or Disco boards, you will get a number on your board. There will be a sticker on which some QR code will be there, and there will be a number. On my board, it is written MB1136F401RE as CE04. So C is cut. So cut 3, cut 4, cut 5. So these are different evolutions that they have created, and they have placed all the schematics here. So mine is a cut 4 board. So I will click on this cut 4 and I will download the schematic. Okay, so I have the schematic downloaded already. It will just show. Yeah, so this is the schematic. I will come to it later, why it is used, how it is used. Okay, other than the schematic from here, you need to download the reference manual from the MCU or MPU selector. So again, I will type F401. Sorry, I don't know why it is slow today. Okay, F401RE. So we have three options here, but if you see, this is the chip on which has the board Nucleo F401RE. So I will click on this chip, and then I will go to the docs and resources, and here down we go. We will get the reference manual. So if you click on this reference manual, you will download it. I have downloaded it already. And other than that, you need to click on this data sheet. This data sheet also we need it for our development. So click on this data sheet and you will get the data sheet as well. Okay, so if we have all the three documents downloaded with us, then we can go ahead and go to our board selector tab, click on our board and click on next. So it will ask you about your project name. You can just type in a project name, 3D toggle, for example, and you can click on next, and this will show which firmware package it will take your code from. So you have different firmware packages installed. So ST, uploads them on GitHub. You can directly go to the ST GitHub page and you can clone your firmware repository from there and directly integrate it in your application, or this IDE installs or downloads the Cube firmware package automatically in the background. So this is the version 1.28.0. If any new version comes, it automatically downloads newer versions of the firmware for the board which you have selected. So for me, F401RE, this is the firmware package that I am using. Click on finish. Now it's asking if I want to initialize all the peripherals with default mode. I want to start from scratch. So I don't want any peripherals initialized. I will select the option no. So it will open the CubeMX, whatever the CubeMX tool that ST provide as a different piece of software, that the same tool, it opens it in the Cube IDE. So for CubeMX, there is a file with an extension IOC is generated. So it's a visual tab that will open in Cube IDE, and it will we will be able to configure different peripherals with the help of that tool. So we got the visuals here. So this is how the MCU looks like. So if you look on your board, there will be a small black chip that this cube MCU is showing here. This is the same chip that is on your board. Now this is in a package called named LQFP64. So 64 pins are coming out of this package, and there are different kind of packages. I don't want to go into that, but this is the LQFP package, and we have these pins coming out of this chip, and these pins are connected to user buttons, LED pins, some oscillators, all these different utilities that are present on our board. These pins are connected to. So we don't start from just the chip. We are starting from the board. in order to get how each pin is connected, which pin of the MCU is connected to LED, we need to open the schematic of the board. So that is the purpose of the schematic. The schematic is always related to a particular board. Now we have this chip. I want to configure a GPIO, and I want to toggle an LED with that GPIO. So here on the left, we have the tabs. These are categorized in the different IPs. IP is the name of the short form of intellectual property. So these different peripherals are an intellectual property of a company. So they are called IPs. These different IPs are categorized as system core, analog. We have timers. For connectivity, we have I2C and UART, SPI. All these different categories we have categorized here. So GPIO will come under the system core. First of all, these GPIO pins are initialized with some values. I don't want any initialization. I will click on pinout, clear pinouts. So I want to clear all the pinouts. So this is a clean project I'm starting with. I want to configure a GPIO. So I click on the GPIO. Now the question is which GPIO I want to configure it. I want to configure obviously the GPIO which is connected to the LED that is present on my board. So if I see my board, I don't know, my camera. Okay. So if I see my board, I see LED3 is different LEDs are named by the name LD, LD2, LD3, etc. Okay. So I want to configure a LED, green LED. Its name is LD2 that is present on my board.
Sumit,
So
sorry to
which,
interrupt you. Maybe you can show the schematic. You
yeah,
can, explain better.
yeah, I
Since
will
you
show
cannot,
the scheme.
show the board.
That is the next thing I was going to do. So how I come to know that where is the LED, what different kinds of LEDs I have, and which pin it is connected to. I will open my schematic, and you don't need to read the schematic really. You majorly just search on schematic. That is the major thing you do. So I will search with LD and see what is present. So okay, I see LD1, but it is connected to ST link. I will go to the next. So, okay, I got LD2. Yeah, I can use LD2. LD2 is a green LED. It is showing, okay, where it is connected. I will go see the connection. If it is a dot, then it is connected. There is a connection, and I see a dot here. So the signal name it is referring to is D13. So we don't know what is D13, which peripheral, which GPIO pin D13 is referring to. So we again search D13. D13. Okay, I got it. So this is the D13 signal. It is showing that PA5 is the D13 signal. So if you know the different GPIO pins, they are grouped together in by port names. So a port is just a collection of 16 pins. So if I have PA, this is group A, and it will have 16 pins from 0 that are named PA0 to PA15. So the GPIO pin that I am referring to, it's the port A, pin number 5. So I want to configure this PA5 pin uh, in order to toggle my LED. So how we can configure it? I need to search where is PA5. So I have PA5 here. If I click on the PA5, then I will get different options here. So a GPIO can be configured, with different configurations. It can be an input, it can be an output, it can be an analog or alternate functionalities. So if we want to drive the LED, so if we show the schematic, LD2 here, so the D13 signal is PA5. It is connected to LED, and the other part is connected to ground with a resistor in between. So what if I put a high on this pin, then a current will flow in the direction of to the LED, and it will glow. And if I put a low on this GPIO pin, then the LED will be off. So I want to drive this GPIO in order to blink my LED. So how will I do it? I have the PA5 pin here. That is I configure it in the GPIO output mode. I will click on this pin. So this is the output level. So if I am not driving any signal, what output I want the LED to be off. If I am not turning, if I am not giving any output on the LED, so this is the output level. I want it low in the initial stage. The mode I want is push pull. I want to drive it high, and I can drive it low as well with my code. So the mode is push pull. I don't want any pull up resistors, and the speed you can choose high. Okay, I can also give a user label as well here. So this macro will be defined in our code. So I have put a user label LED green. Sorry, it's taking time.